in the next thing. So we are working on the list. Within the list, we have worked on few of the data structures. I told about the different operations that we can work on the list, and including some of them are to the sorting. Sorting is one thing, but like we have discussed on other attributes also. Till now we have seen like how to add, how to delete, how to remove all the values in a typical list. Similarly, we have seen sorted also. I told there are two tips. One is like sort attribute is there, which will do in place changes. Means after doing this, the changes will be reflected on the original object. Whereas if you do with the sorted built-in function, it will create a new object, but the original object will be as it is. That's for sure. Now, what I want to bring to your notice is, if I say names again, I will get it. So by default, names you have given in one order. It may not be ascending, it may not be descending, because when we give in, we will give in one order, right? But when you are sorting, we can sort in a ascending or descending order based upon different things. Similarly, if you have given in one order, okay, so if you see A is starting in the last, so C first, so B and then D, something very, there is one function called as reversed. Sorting in a reverse direction is different from reversed function. What this reverse function does is that it will create a iterator object. This is very, very careful, you need to be off. Reversed means it will change the values, the order in which the values are coming. But in fact, it is creating something called as a list reverse iterator. For the first time, you are seeing a concept of iterators. Means these are kind of like, optimized objects when we're working with a large data. So by default, you cannot understand anything. So if you want to get the values, either we need to do for loop or convert to another object. Say reversed, I'm assigning to some other object. Reversed is equal to, so this one, if I assign, if I ask the values, hey, give me the type and the values, type of these values and the values. As I told, it's a list iterator. By default, you will get like this. So if you want to process, either convert to a list or some other data type. So I convert to a list. Now for the same values, if you can observe, did you see how the order of the values are coming? So the existing values, what are the order is there? Don't you see that it was just reversed? It is not ascending or descending, reversing the original order. Reversing the original order. And also, in the same fashion, after doing these things, if you ask, hey, what is the names? So the changes were not reflected on the original object. In the same lines, if I say names dot reverse, there is one more attribute. So built-in attribute means what? Changes will reflect on the original object. Then if you can observe, did you see that it is changing on the original object? And observe, this is not an ascending or descending, nothing to do with the ascending or descending order. Just reversing the order in which you gave, that's it. It has like as any order, right? So whatever the original order is there, just reverse. So this is same like, you doing a colon minus 1, right? Colon minus 1, if you do, that also we get the values in a reverse order. So similar to that, reverse will do. But it will, if you want the changes to be on the original object, you do a dot reverse attribute. So if I do like a reverse, the existing value is reversed already. That again further it is reversing, means again the original order. But if you want to create a new object, you can go for reverse function. So that's the difference between those functions. So to list out, we have like sorted built-in function versus list.sort. That is one thing. And similarly, reversed function versus list.reverse versus the list colon colon minus 1. So these are the different things I told, right? To summarize. Fine. So after these things, let's move on to the next problem. Before even going, let me tell you one very, very interesting problem. So which is called as the copy problem. What is this concept of copy problem? Let me tell you. In fact, I created one of the videos. Just walk through it. It will be very clear to understand. Basically, now we have entered a scenario where we are working on a data structure. Means it's not the actual data. Means actual data means what? Int, float, so strings, none, boolean, like that. On top of that, we are working with these things. The basic data types, if you see like int or a float or something. Okay, let me define like a numbers like this. You see, in this case scenario, first I'm defining number 1 is equal to 123. And I'm asking, hey, what is the value? What is the type? What is the address location? Then in the second case, I'm assigning number 2 is equal to number 1. Now, after assigning it, if you observe carefully, did you see that? So as you have assigned, both are representing the same number. Okay. But if you are assigning number 2 with some other value, say number 2 is equal to 999. After doing this, did you see that when you have given a larger number, the address location is changing, right? So, and if you are going for a mutable object, how it actually works, I will tell you. So, if you are taking one object, okay. So I am taking like parent list is equal to 11, 111, 1111, like the 3 values I took. And I'm asking the values. So it will say this is the values. It's of type list. It is having some address location. So I am taking another list called as like this. I am creating a new called as hard copy list. There is nothing like hard copy, just to mention. Generally for integers, till now you have assigned in this way, right? If you assign something and if you modify one of them, the other value is not changing. Observe carefully. When you initially made number 1 is equal to 123 and then you assigned, both are having same value, same address location. But subsequently, if you changed the number 2 value, the address also was changed. And number 1 was not affected, right? Once you make this relation, if you change one of them, other is not reflected. Whereas, if you go for mutable objects, so a list, if I am assigning like this, you know what will happen? Same in the same line, if I ask, hey, what is the value, what is the type, and what is the address location? Did you observe that? Same values, same list, and address location is also exactly same. With this, what we can understand? You know, when you are assigning like this, it is not creating a new object, but referring to the existing object. So then what will be the problem, sir? Now, if I take that, let's say I want to go for second value. In the parent list, what is the second value? You know, every time remember indexing start from 0. Zeroth value, first value, and second value. Means 4 ones is the second value, right? If I ask, it will tell that. Now, the second value, I want to change to something else. Obviously, we can change, right? It's a possibility. So I am changing there. You know, this is the concept of substitution, as I told you. So you take a value and overwrite it at that position. That is substitution. The moment I substitute, you can notice the difference. Did you see that the value was changed when I substituted? This is fine. So then what will happen, sir? What is the problem? The problem is that, so after you took a original parent list and you are making some changes, and after you are making changes, you are asking, okay, so 11 is there, 1111 is there. The second value modified. Okay, you took a parent list, you changed it. But the problem comes like this. Okay, you know, wherever you changed, it should have effect only there, right? But if I take this hard copied list, So I didn't change anything in the hard copied list. It should not have a leakage. But the problem is like this. What is happening? To repeat again, first you created an ordinary parent list. So, and then from that you did a direct assignment. Due to that assignment, instead of creating a new object, both are referring to the same object. It's like, two slice, two labels on the same bread. So then what happens? If you are changing in the parent list, so parent list value will change. That is okay. But at the same time, the hard copied list is also having a changes. So simple. If there are, why you take a one copy? You want to do something else with that. Just imagine like you are going in a chemical lab. So you got like a blood sample. So on the blood sample, you want to do different tests. So that's the reason we isolate different parts, right? You take some sample and do one operation, some sample and do some other operation. What if you are changing something, it is affecting the other sample? It makes no sense. So like that, when you are changing one of them, it is having the changes reflected in another also. This is one of the biggest problem. So when it will happen? Only for these mutable objects. Mutable means the objects which support in-place changes. The first and foremost such object you are seeing is list. Then you will see like a set, dictionary. Those also support like this. So the problem is there also. For immutables, there is no problem. Only for mutables, there is a problem. Then how to solve this, sir? There are like multiple ways to address it. So one way is like using the copy module. Copy is a module which we can use for creating anything. So there is something called as a soft copy list or a shallow copy list. So using copy.copy of parent list. Okay, whatever the changes were done till now, fine. From now onwards, there should not be leakage. So instead of assigning like, so new list equal to directly, we are doing copy.copy of existing list. Now, if you can observe, did you see? The address location is quite different from that of previous ones. Did you see that? It is 3040, 3040 first two things. But for this soft copied list, the address location is different. If you so if you make any changes to anything, so it should not affect the others. That's the whole point. And now if I go to this hard copied list and if I make some changes to it, it should not have an effect on the others. Say in the hard copied list, I'm going for the second value. In the hard copied list, second value is 333, right? I want to change it to some other value. Say I want to change this value to something else. Say 4, I want to change. And observe carefully, I am writing everything here itself. After making one change, all the things I am making in one list so that you can see. When I made changes to the hard copied list, it will affect only the parent list because both are like directly assigned. But did you see that soft copy list was not reflected? Means what are the changes you did? So they both has the relation, but your soft copy list was not changed, right? So that is one advantage. Similarly, if you make similar changes on the soft copy list, you created a soft copy list. For that soft copy list, I want to make the changes. Then it should not affect the other two. That is what my expectation. So let's see now. If you see the soft copy list, I am asking for 0th value. The 0th value is 11. I want to change to 0. Then, as per our word, only the soft copy list should have the changes. Did you see that? So when you are making any changes to this one, so it's not affecting the others. Others changes are not affecting to this one. So don't you think it is a isolated copy? So this is what the actual advantage of going for this one. Similarly, there is one more copy called as a deep copy. So like shallow, this is called a shallow or soft copy. Then another thing called as a deep copy. To understand more about the deep copy, let me take a fresh list. I took a list of values. Now for this list of values, I want to create the copies. Using the copy module, I want to create. Anyhow, you know the very basic assignment has an issue. I ignore that. But using copy module, copy.copy of the existing list, copy.deep copy of existing list. So the first one is the shallow soft copy, second one is deep copy. Like that, I created two lists. So what is the advantage, sir? The moment I created it, if you can observe that, I'm making a print of all these things together. If I create, if you observe carefully, I'm asking, hey, give me the values of these things. Okay, if you observe carefully, what I'm asking here. Okay, if you observe carefully, the original list I'm printing, along with that, the soft copy and deep copied list I'm printing. And if you observe the original list, you can see, and like its data type, so address locations. And soft copy, its address location. So deep copy, its address location. Did you see that all three have three different address locations? It means that these three objects are created in three different locations. That's for sure. So then what is the advantage, sir, of going like this? So the moment we have done like this, if you make changes to one, it should not reflect to the another. Let me take one deep value. If I take like this, new list of 2 of 2 of 1. So in this, what is the second value in the new list? 0, 1. This entire is like a second value. Within that 0, 1 and 2 means like this is entirely a second value. Within that 0, 1 means don't you think you are asking for 441? Now in this original list, I want to change the value. So the value of this one to some FFO I want to change. So after making this change, again I want to see each of these three values. Hey, what is the value? Finally, like that I want to see. So whatever the original values are there, right? Let me print again. I made the changes and see. So in the original list, when I made a change in the deep value, so did you see what happened to the new list? Deep within it, I made a change, FFO. And did you see what happened right now here? Okay, it didn't execute. All right. Yeah, I didn't execute. Yeah, I changed it and I'm asking now. Yes. If you observe this carefully, means shallow copy will be good for the first one single dimension. But if you have like a list within a list like that, if we have, in that case, shallow copy will have a problem. The problem is very simple. I have gone for deep within it. Two lists below, I have a value which I changed in the original list. In the original list, I changed the value to FFO. So then if you see in the original list, I changed it to FFO. And did you see that even the soft copy also has that leakage? Means once you have a single dimension, it will work. But if you are going for multiple dimensions, shallow copy doesn't work. So, but deep copy, did you see? Even if you go deep changes also, it will not having any issue. So this is what I want to prove actually. So if you are going for a shallow copy, it's for one purpose. Deep copy is for another purpose. But so should I go every time for deep copy, sir? Because perfect replica means it depends. Shallow copy is basically faster because it's a single dimension. So whenever you are going for a single dimension, it's recommended to go for a shallow copy. Whenever you are going for multiple dimensions, it's better to recommend for going for a deep copy. And not only that, one more thing I want to bring to your notice is that, let's say I have taken one more list called as something like this. So if you want to create a copy, the copy can be done in alternatively other way also. If you create like this, so the existing list of colon colon, I'm not saying colon colon minus one, just colon colon. So like this also I can create a copy. So if after this, if I ask, hey, give me the values of both the things, hey, print the ID of both of them. Did you see that the address locations are different? So we are not assigning directly. If you assign directly without this thing, it's a direct assignment, which will have an issue. But if you do like a colon, it will take a slice and do the assignment. In the same fashion, if I have a list, multiple dimensions like this, okay, why I'm telling, because it is a shallow copy, because if I do like this, I have a multiple dimension list and I made a copy. And if I'm asking, hey, what is the address locations? You can see that both address locations are different. But if you make changes to one of them, it will reflect the other. So you know the concept of short copy, right? So whenever you make changes to one of them, the others also will reflect. To understand, so I can say like f of L3 is equal to L4. Yeah. If you see now, so what are the changes you make to the original list? It is reflecting to the other also. Means for ordinary things, it's not reflecting, but others also it is reflecting. In the same fashion, we also can create a new list, like list 5 is equal to say list 2 or list 1 dot copy. This copy attribute, this is also one kind of soft or shallow copy. Shallow copy. So to summarize all these things, so we have like soft or shallow copy. So soft or shallow copy can be done in multiple ways. Copy dot copy, if you do, then also we can create a shallow copy, or like so list dot copy. So like this also you can create a shallow copy, or list of colon. Like this also you can create a shallow copy. But deep copy, how do you create? Using copy dot deep copy. So these are the two things summary we have learned. So based upon these things, I have some assignments for you within this list. So the assignments are very simple. You can try doing on your own. So first and foremost is I want to work you to work on um, yes. Okay. The first assignment which I want you to focus is implementing a stack mechanism. So you create a stack mechanism. Stack means what? It should take like a input. So like a push, everything should be in one direction only. So we can add an element. Pop means to delete a last element, and status means stack size. So you have three operations like pop. List.pop means it will remove the last element. For pop, if you don't give the position, by default it will remove the last element. So and append means it will add in the last positions only. Means don't you think all should happen in one direction only? So don't you think we can implement? And if you want to get the current size, we can use the length built-in function. So like that, you can also implement something called as a queue mechanism. Queue means like first in, first out. So inserting in one direction and deleting in another direction. So you can use insert with a position of 0 such that we can insert there. Whereas a delete means, so pop means it will remove the positions. Based upon these two, so try to complete these two assignments. I think it shouldn't be a big deal. So you can do on your own. And like one more thing I want to bring to your notice is about the list. So basically list is so vast that we need to understand one more important point. There is a referencing problem within the list. Whenever you're creating the list, so the most common problem that people face, I will tell you. Generally, if I create any list, like say my list is equal to an empty list, then what will be the value? It is an empty list, right? There is nothing wrong. But if you multiply the same list with the 3, It's an empty list. You are multiplying with 3. Then what will happen? I get like empty list into 3 means what? I get the same thing. But there is one anti-pattern. Anti-pattern means like the one we should not follow is called as an anti-pattern. So one which will result in some problems is called as an anti-pattern. This is a programming terminology. Anti-pattern means. So what it actually happens? Whenever you have an empty list and you multiply by 3, so even if you multiply by 3 also, you get the same answer, right? Let me write both in the same place. In both the places, you get the same value. Whereas in anti-pattern, what it actually happens is that if I multiply by 3, I get 3 values like this. So then what is the problem, sir? The problem is that for one of them, let's say, I am going for the 0th value here. Means my list one of 0 if I ask. 0th value means what? Again, it is an empty list, which is this value, right? So this value, if I am trying to append something, say some 3. Now we see, okay, changes were happening, but what will happen? You think that, whatever the changes you do this one list, it should only have that effect. But what it will happen if you see, you'll be shocked. Did you see that? You made changes to only one value, but it is reflecting in all others. So what is the reason for this? The reason is simple that whenever you're creating a list, within that there is a list, all lists are referring to the same object. Due to that, if you change to one of them, everything else is affected. Similarly, if I say my list one of say second value is equal to some 2 if I give. So after that, if I ask, hey, what is the my list one? I think like I made a mistake spelling. So type. Okay. Okay. If now, so if you overwrite one of them is fine. But like if you are, appending and other operations, so everything is getting affected. So what is the best solution, sir? Whenever you want to create like a multiple list, so instead of creating directly, there is an alternative way called as comprehensions. Using comprehensions, you can create. Next, we will discuss about these comprehensions afterwards. It's a very simple thing. So you do for loop in a single line. That's called as comprehension. The for loop, you need to for 3 times. You loop it and create an empty list. And if you do like this, if you make any changes to anything, so it will not reflect the original object. So if I create like this, everything will be there. And if you create like, so any changes also, the changes will reflect on only that object. You see now, if I go for the second object and I make changes, it will have only effect on that. So like that, whatever object you create, it will have its effect like that. So this is all about the basic list. Then tuples are not that difficult. It's very easy because it will not support too many operations. It's very easy to understand. So a tuples dot ipynb. So we can you can see that so tuples are like represented using parentheses and they doesn't support in place changes. So what is this data structure? Means if you take like a simple example of what we have seen till now, the list means what? It will take both homogeneous or heterogeneous, any type of values. Even a list or a tuple also can be stored. That's why collections are called like that. Any data type you can store. And overall it is called as a list because it is stored everything in a square braces overall. And individually each one retains their own data type. And if you want to get the type of overall, so it is we can call it as of type list. And if you want individually, also we can see. Okay, first we need to select the kernel. Okay, fine. You see that overall it's a list containing all the values, length and everything. Now the same example I will take. So, and instead of these braces, I will change that. So I call it as a my tuple, and I will change the braces. I am changing the braces from square braces to parentheses. So within this, it can have anything, but overall outside, I am changing the braces to parentheses. The moment I change it to parentheses, it's called as a tuple. So tuple also has the same kind of attributes like a list. So we can also index, we can also do all the operations. But the only difference is that, so we will store the content in parentheses. What is the one unique property here is that once created, we cannot change the object. Means it doesn't support in-place changes. Similar to how we do on a typical strings, the same thing here. And one more thing, so about a tuple that we need to learn is whenever you have a single value. So whenever we have a single value within the tuple, 99.9, something I have. So I have a single value, right? Only in the tuples it will have an issue because hope you remember even when you're doing your mathematical operations, use the parenthesis, right? During the PEMDAS I told. Then how can it recognize whether it is a mathematical expression or a tuple? So mainly the problem comes when you have a single element. So when you have a single element, it is saying that it is of type float, and it is saying that there is nothing of type length. For floating point value, we cannot ask length, right? It is thinking as if it is a so and so. What is the problem, sir? So mark my word, every time when you have a single element, ensure to place the comma at the end. So this is the most important point. So ensure comma at the end if there is single element in tuple. This is the most important point. The moment you write a comma, it will become a magic. That's called as a tuple. So whenever you have a tuple with a single value, so we need to ensure that there is a comma placed at the end. This is the most important point that you need to be aware of. Okay, is it clear? And similarly, sir, what if I want to create an empty tuple? If you want to create an empty tuple, you can just create these braces, or there is a tuple built-in function that also you can give. In either way, it will create an empty tuple. So when there is empty tuple, there is no problem. Only when you have a single value, tuple will have an issue. So we should ensure the comma. That's the main thing. In the same fashion, tuple is so interesting in such a way that if you have like a multiple values, I don't have any braces. So if you don't place any braces also, it is treated as a tuple only. You see, if you have braces also, depending upon the braces. Till now we understood about the square braces, which is a list. And the next one is parentheses that you are seeing right now. But if you don't place parentheses, braces also, it will treat like this. So means like if I have the same tuple, so if I say like, my tuple is equal to 1 comma. If I ask like this also, hey, give me the values, I have a single value and I have a 1. Observe carefully, if I have a just 1, it will treat like an integer. The moment I have 1 comma at the end, it will treat like a tuple. Hope you understood how this works. So that's what makes it more interesting. So so comma is like so much interesting. It has its own value to help us. Next, now we understood how to create a tuple. Let's go further into the tuple attributes. So let me take one tuple and observe carefully. Here deep within also I have a comma. So the moment I have a single tuple, within that I placed a comma. If I don't have a comma, it will treat like an ordinary element, right? So that's the point. So if I ask, hey, what's the value of my tuple? Observe carefully. In the first case, I don't place a comma. I will ask, And in the second case, I'll place a comma within it. Did you see? In the first case, within it, I didn't place a comma. So though I place the braces, it will treat like the part of the same dimension. But in the second case, within the braces, a single value is there, I placed a comma. That's why it is saying, so tuple within a tuple. So this is what we should be aware of. Next, with this tuple, what we can do? So to understand the list of attributes, we have the dir built-in function. If you give, it will give the list of attributes. The very basic, did you see? It is giving an add, but not I add. You remember? In a list, we have like I add and I add, mul and I mul. So like that we have all. So the I add won't be there, like I mul won't be there. The remaining operations will be there. Mul is there, addition is there. Means how we do like a list repetition operation. All of them we can do here also. Means the first thing is like length. If you want to calculate, so length built-in function or tuple dot underscore underscore length. Like this also we can do. Or if you want to convert something to a string, I can do directly also, right? So I can do directly or like this. So to make you easy for you to understand, I wrote an assert in the last. str of tuple or like tuple dot underscore underscore str. So both will work in the same way. In the same fashion, if I do like tuple repetition operation, for the tuple repetition, so there also I told you. So if you multiply tuple into 3, or like if you do like multiply, so both will do the same job, but the original object is not changed. So, and I told in during addition list that imul is there. If you use that, in place changes will happen, but imul is no more there here. And similarly, if you want to check whether two objects are equal, so for the tuple equal to, we can use operation or like underscore underscore equal. I'm checking like both are equal or not. So similarly, you have seen all kinds of like, underscore underscore attributes. And if you want to get the list of all the attributes which don't have an underscore, so I told you, right? So we have done a similar structure. We looped over each of the attribute, and as each attribute is like a string, so I checked with starts with. If it is not starting with an underscore, I want to print it. So finally, without the dunder methods, if you see, there are only two. No append, no extend, no insert, no pop, no remove. So nothing. So means whichever attributes which are leading to the changes were no more there. And which are the objects which are not leading to any changes, those we have seen. So it's same like a list, but without any changes. So if I take like count, the same thing right? Count means what? At base level, how many values are there? If I ask, hey, count of 5, how many times 5 is present? Overall, there are 2 5s, but at the base level, there is only 1 5. So here, there is 1 5 like a tuple we have. So that's a difference, right? Similarly, if I ask for any values, and if I ask like its count, it will tell what is the count of it. If I take like one more list right now, and I'm asking, how many times 5 is there in this case? So I have a value, but I didn't place a comma at the end. Then what will happen? It will treat in the base dimension. Then obviously, if you ask, it will give two values because 5 is occurring twice. In the same fashion, if you want to get the index means what? You give a value, I will give you the position at which it is present. So if I ask like, hey, give me the index of 8, what is the position of 8? 8 is present at the third position. And similarly, I'm asking the index of 5. If a value is present, it will give the first occurring position. So 5 is occurring at the first position and also the fourth position, but it will give the first position. And like if you are asking for something which is not present, then it will throw an error. So if I'm asking for 55, which is not there, it will throw a value error. And how do you handle the try exception, right? I showed you. So these are the basic attributes. And you are telling every time that, tuples are immutable. So, but like, can we do some more operations like concatenations, others? Yes. So though officially it doesn't support, so we can do it. So the point is, Python is a strictly typed language. If you ensure that both the data types are of same type, then fine. You see, in the first case, I have a tuple of two elements. In the second case, I have a tuple of single element. That's why I placed a comma. The moment I placed a comma, it's a tuple. So then I can do the operations. Sir, why this is happening? You told tuples cannot be edited. Means these two tuples are not changing themselves. They are creating a new object, right? As they are creating new object, it is possible. Similarly, if I go ahead with the next one, if I have a tuple within another tuple like this, then we can do this change. Sure. You see now, if you ensure that both are tuples, then things will work. So I have a tuple within another tuple and I place it together like this. Means within the single tuple, I placed it. So then what happens? The entire result will be part of another tuple. So like that, I can do different operations. So ensure that both are of same type. If both are of same type, we can do operations. If both are of different types, we cannot do the operations. If you take one example like this, you see in this case, both are tuples, so we can create a new tuple out of it. But in case like one of them is not a tuple, you see, in this case, one of them is a tuple, other one is a list. Then we cannot do the operation because Python is a strictly typed language. Then what it actually expects, convert them both to the same type and do the operation. Means if you want to do the conversion, we have the built-in function called as tuple. Either convert the list to a tuple or convert the tuple to a list. So either we can do. So the built-in functions are list and tuple. We can use the same things. If we have another data type, which is an iterable, all iterables can be converted to another data types. So we can use a tuple for converting a list to a tuple, or like a list built-in function for converting from a so this list to sorry tuple to list. So in the first case, all both will create a tuple. In the second case, both will create a single list because based upon that we are doing the operations. Not only that, these can also help. These built-in functions can also help to parse on a string or something else. If the same list and tuple I'm using for parsing, so it will take each of the character and make it part of a list or a tuple respectively. So not only this tuple operations, a tuple also supports the tuple repetition operation as I told. If we give a tuple and multiply, the same tuple will be repeated those many number of times and it will create a new tuple. In fact, both are not actually affecting the other, right? So we can do it. So based upon these things, a small assignment for you. Take two tuples and check whether it is commutative or not. So the addition of two means concatenation of tuples is not commutative, I am saying. Even for list also we proved the same thing. So if I add them and reversely add also, both are not same. But if you do the repetition, which is a commutative, if you do in either way, it is the same. So try to do that assignment. And also, I am telling that this is the most important point. Tuples are immutable. So tuples are immutable. Means they doesn't support like in place changes. So this is the most important point, right? So if you want to check that, yeah, you can give it a try to understand that. You take any list, any tuple, and you get a particular value and you try to change it. You see here, I am taking a tuple of 1, 2, 3. In that I'm asking, hey, what is the second value? Second value means what? Indexing starts with 0, 1, and 2. So what is the second position? 3. So if you ask, it will say it is 3. Now this 3, I want to change to something else. So whenever I want to change, I want to do like this. Whichever condition which can prone to, exceptions, we write in a try exception. It doesn't mean that it will result in an exception, but I understood that in this case, it will throw an exception. That's the reason I handled. So it will throw an error, which is type error. Means it doesn't support item assignment. Means in place changes we cannot do. But if you want to overwrite, that is possible. Overwrite means the entire values if you want to change. That is possible. So the same thing. Tuples are immutable. So the next point I want to bring to your notice is, so whenever you have a tuple, say like, you have 2 values, 3 values, 4 values, but over a period of time, the values will increase, right? So then in that case, till now we know tuples can be assigned and worked based upon their position. There is one more thing called as a named tuple. There is one more thing called as a named tuple. What is this named tuple? How it can help us? Let's see. So if I see here, what is this named tuple? How it works? Till now, if you have any list, I can assign and get the values based upon the position, right? So let me take a small list. I have a small list called as 3 values. So 0th value is Arjun, 26. So like that. If I want individual values, I could say like, hey, give me the students of 0th value or students of first value. Like if I ask, I get the values. But can I tell by the position? Means for every position, if I give a particular name, and it means like first one is the name, right? Second one is age. Third one is date of birth. Can I say like, name, student details dot, date of birth? I cannot get the values. So when you go for large number of values, that is much more advantageous. So if you want individual values, the only way you can have is using the index. If I want like the name or age or date of birth, I should give the 0, 1, 2, 3 like that. So assume that there are tuples which have a proper structure of data. So if I want to access with their so-and-so, for that I need to work on a new module called as collections. For the first time you are learning a new module called as collections. This collections has a lot of attributes which we'll see afterwards, but we need only one part of it. So whenever you want to do, first step is like to create the data structure. Okay, here we have the case of Arjun, age and so and so. Means we have like, there are 3 parts, right? So the first one is like a name. Second one is like age that you have seen. And the third one is like date of birth, which you have seen, date of birth. So these are 3 values are there. These 3 values I have taken. These 3 values I want to assign to a named tuple. So for that, if you want to create, and maybe like these are student details, right? Maybe I will assign to a variable called as students. I want to assign. Then how I need to create is student is equal to collections dot name tuple, and within that also we should give the same name. Of course, this is the structure we need to follow, and whatever the positions we have, we need to give it. Means you have Arjun 26, some date of birth, right? We have 3 values. So for the 3 positions, I give 3 names. And you are creating like a data structure kind of thing. So for that, we need to assign some name. Means for an ordinary tuple, just a values you take. But as we are need positions also, so we are giving some name. You may ask me, sir, why the same name in both the places? Because they made a structure like that. So that's the best practice. So we need to follow. Now, till now, after creating this structure, if I ask, hey, what is this type of the students? And I'm asking the values. In fact, you didn't create any values. You created one data structure with some positions with 3 values. It is saying it's of type only. So it's not like custom type, right? It is saying like of type students. It is not saying that I'm of tuple or something. But then how do you create a new student, sir? Till now, if you want to create a new tuple, this is how you create, right? Student tuple. But with this, if you want to create, so you need to pass to this function, this variable. So I need to pass to this students of this one. So maybe like I want to create student details 2 instead of this values 1. I want to create student details 2 is like this. So ordinary tuple you create directly with some values. But if you want to create a named tuple, first write the positions. But after that also we should ensure to pass only 3 values. If you pass 4 or 5, then it doesn't work. So ensuring that you are passing the same number of values, you can create. And after creating this, if you ask, it is like a typical tuple, and I'm asking, hey, what is the type? And I've asked values. It is saying that I am of type main.students. And the values, the moment I asked, did you see how it happened? You passed 3 values. So because it need 3 values, it has taken. And after that, what happened? So name is equal to Arjun, age is equal to so and so. You didn't say all these things, but it has done in the backend. Now, in terms of accessing, I can access like a traditional tuple by using their position, zeroth value, first value, like that. Or at the same time, I can also access by their position names. So by the position names also I can access, directly also access. You see now what happens? If I access by zeroth value, first value, second value also I got. At the same time, dot name, dot age, dot date of birth also I got it. So like that, I created one data structure. So for usage. So hope you understood now. So down the line, you will see a lot of attributes like this. The concept of attribute means, right, you have an object. With respect to that, you do a dot and you ask the values. That is the concept of an attribute. If you want to get values from an attribute, so either we can do a dot, so like this, or in the back end, there is one built-in function also called as getAttr. Means like you can ask directly or indirectly. Means if I ask student details to dot name or getAttr of student details comma name as a string, both will give the same value. Now tell me, are you interested in this getAttr function or directly accessing like this? Definitely no one want to do this kind of thing, right? But in the back end, this function will execute. So this is another built-in function that I'm telling you, getAttr. In the same fashion, so if you want to get values of something which is not present, so the student details basically has 3 values. And if I ask fourth value, it will throw an index error, right? Which we know. Similarly, for this particular student details, we define 3 things. So what are the 3 things we defined? So name, age, and date of birth. But what if I ask it for like, say, full name? Then also it will throw in error, right? It will say that attribute error. Observe the difference. When you index a new value, we are getting like index error. But when you are asking a attribute which is not present, it will say like attribute error. For the first time you're seeing, right, new kinds of things. So this is like a index error, this is like a attribute error. So similarly, if you do the same thing with a getAttr also, the same thing will happen. So both are referring to the same thing, right? When you don't have a value and if you ask, it will throw a attribute error. And the beauty of these built-in functions is that we can also check whether an attribute is present or not. If you want to check whether an attribute is present for something, traditionally how you do? You do a DAR of the student details too. You get the list of all the attributes. Within that you check, hey, do you have like date of birth? Do you have name? So if it is a list of values and if you want to check, don't you think that you check like this? You check like this only, right? Instead of you doing this much and doing, there is a simplest way called as a has attr. In fact, has attr also does the same logic like us. Whether you do like this or like this, so both will do the same job. Okay. So if I use the has attr, Has attr checks for the particular object is present or not. If it is not present, it will say false. This is another built-in function. Like get attr, if nothing is there or not, it will give the value. Has attr checks for potential thing. If it is present, it will give. If not, it will not give. So based upon these things, instead of I getting to an exception handling issue, I can do smartly like this. I am checking that, hey, has attr of student details dot full name means if it is true, then get the attribute. Has attr of this thing, if it is there, then give it. Then what happens? Only if it is present, it will go inside. So it will never go inside. So in this case, it will go and give me the value. So these are the three things, like has attr, so get attr, so and this thing. And similarly, there is one more thing called as set attr, but at this moment we cannot do, because named tuples are also immutable. So like a tuple, named tuple is also immutable. You cannot change a particular value at a particular position. If I go and ask to change the value, it will throw an error. You cannot change the value. At the same time, you cannot set a value. You see what it says? Attribute error, can't set an attribute. You see what? You cannot set the value, you cannot set a new attribute. So like that. In fact, like if something supports, like if you go for a list supports it. For a list we can do, as this is the same operation, like setting an attribute. For the object, what is the attribute and what is the value? So these were the three functions. So conclusion is that, so here we learned about three functions, like get attr, so has attr, so and like set attr. And there is one more thing called as the del attr. So not at this moment, but still a lot of learning is needed to get to there. So but I want to just tell you. So this is all the journey of a named tuple, how it can be used and others. So we can create a named tuple for different scenarios. So for better working. So if the simple example is, let's say if I'm going for a ordinary Cartesian products, let's say I have 2 points like this, and if I want to do some operations, so generally what I do, like using based upon the references, if I want to do, so means I want to take the first point zeroth values, second point zeroth value. So like that, I want to do some operations. Okay, assume that I am taking the math import and I'm doing some operations. So whenever I'm referencing each of the point, I'm saying that zeroth value, first value, like that I'm referencing and I'm doing my job. So you are taking this much struggle to get to it. But if you are using a named tuple, things would be much more easy. So import collections, import collections. So we can do like, I can create a point object. Point is equal to, so collections dot name tuple of whatever the point I want to make. I told the same thing. Generally, we will make a first letter capital. That's the best practice. And we have two values. So what are the two values? Generally the X value and the Y value, right? So either we can give both of them like this. So, and you see now, if I want to create the same point, instead of directly creating, I can do like that, passing to this point function. So this name tuple, instead of directly creating, I pass through it. So due to that, instead of I directly doing, I can refer them indirectly. Instead of doing like zeroth value, first value, I am doing like, did you see? Dot x, dot x, dot y, like that. So like that I can refer. So that is the advantage you get. Means it's a comfort actually. So to be frank. And also the point is, when you're creating a named tuple, it doesn't mean that the value should be like a tuple again. In fact, you can give these values like a list also. So that is also a possibility. Just you need to give two values. So not only this list, we can also give them like in a single string x space y. So ensure that you are giving properly. If you passed like two values, in that case also it works. So it doesn't matter like what you are doing. So, okay, hope it's fine. So like that we can do. So instead of a tuple, we can use like anything. So for the notation to pass. So if you are able to pass it, it's gonna work. Hope it's fine. So in the same fashion, let's go for the last thing called as unpacking. This concept of unpacking is so interesting that generally this is agnostic to anything. So means like irrespective of data types, we can do the same things with the tuples, lists, what are the iterables. If something is an iterable, we can do this unpacking. Means it should have like more than one value. So then we can do this operation. So what all things we can do? So if you see like, first, let's say there are two values. If you are defining two variables in two values, you see what will happen? In two lines, I'm defining the variables. And if I ask the values, you can see that. So whenever you have two variables with two values specifically, we can do the same assignment with unpacking also. Means instead of you defining in two separate lines, you define both the variables in one place and both the values. And the values will go correspondingly based upon the positions. If I have a two values, the two values will go exactly like that. Not only just two, you can have like any number of variables. In this case, I have five variables and five values, and every one will go individually. The first value, zeroth value will go to the zeroth position, first value for second value, like that. Every one will go based upon the order. But in the unpacking, we should ensure that the number of variables, number of values, both should be equal. If there is an asymmetricity, means if they have like four variables and I have five values, then it will throw error. So too many values to unpack. So during unpacking, two kinds of errors comes. Too many values to unpack means so you got more number of values than so these things. In the same fashion, there is one more kind of unpacking error that you find is you have like say E5, 6 means you have more variables. Now in that case it says two less enough variables for like unpacking. So both are not correct. You should give exactly as needed. How do you address these things? Means so, and one more problem that you people face is that what if you have all variables in one side, only one variable on the left side? In this case, it's not an unpacking, it's a tuple that we are creating. And if you have like, two values, two variables on one side and the values, then things were not there. So then how to do it in this case? So the variables and the values both are not matched. So in this case, whenever you want to do, so we can go with a slight difference where for the first time I'm using a new operator called a star. Means, okay, you have a difference in the number of values and variables. Then what we need to do? So give the first variable to the first value and remaining how many values you have, all of them assigned to the second one. So this kind of syntax works only in Python 3. So what they did is like, you give like this. So whatever happens, it will do like this. You see now, one more case. I take like, number one. So N1 is there and last value will go to the last one. In middle, how many values are there? All of them will go to the star N2. Sir, can I go with like multiple stars like this? Give a try. So you have like multiple values. Say in this case, so I have N3 and also like, star N4 I have. So there can be only one star. If you go like multiple stars, then will be an issue, right? So you can have only one star. Then you got the values. If you are asking, hey, now in this case, what is N1? You got it. What is N2? You got it. N3 and N4 if you ask. So those also will give. Let's say I can ask, hey, what's the value of N3? What's the value of N4? You see now? So like that you got it. So finally, this is the concept of unpacking. Whenever you have like multiple values, how do you assign? So that's the point. And the next data structure that we go is sets. Coming to the case of sets, how the sets will work. If I go for this data structure, it's a very simple data structure to work with. So sets basically are used using these braces. Till now you worked with square braces and parentheses, but for the first time you are working in these new braces. So what is the point of going for this parentheses? In which cases it can be useful? Let's see. First, let me explain the most common use case, then I will explain the properties. So assume that I have a list of values like running ports. Whenever I'm reading the port, sometimes duplicates are coming also for me. If you can see 11 is coming twice, so 11 is coming thrice. 44 is there, 22 is coming twice, like that. If I ask, hey, what is the type? It says it's of type list. Total values are 6, and the running ports means you got it. Now from this list, if I want to get the duplicates, I want to remove the duplicates in the list. Then how do you remove? Means if you want to get the filtered list. So first I create a filtered list, and for that, first I go for like each port in running ports. I go and I check like every time when within the loop, I am adding the values to this filtered list dot append of each port. So finally, I want to check what is the value of this filtered list. Now we see again I got the same list. Now, so one slight condition I will do. For the first time I will add, and every time subsequently, if it is already there, I don't want to add. So to check whether it is present or not, I am checking in this filtered list. Each time when a new value is coming, I am checking whether it is present or not. And did you see now? For the initial time when they came, it is false. But subsequently when they were repeated, it is true, right? So based upon this condition, I will do. So if it is present, I don't want to do. Means I will do a continue. You see, know what I'm doing? Continue means like if it is already present, I don't want. So continue means what? It will not execute the next step. It will skip it and go to the new one. Now in this case, did you see now? You got the values which are unique. So filtered. And now if I ask for these values, hey, give me the length. So the length is like 3 elements and the values are like this. I did this much logic, right, to get the values. But if I want to get the unique ports, same unique ports, if I want to get, instead of doing this much hash, so what I can simply do is that whatever the values I have, I can take within these braces. Just take within the braces. Now, if I ask, means, hey, what is the value of? So print of type of these unique ports is equal to. Similarly, as type is there, we can ask the length also. And similarly, we can ask for the values also. If you want to get the values, you get like this. You see now, in this case, what happened? So now it is a set. You got like 3 values, and this is the thing. Here in the first case, I did this much logic to get the values. But in the second case, I just placed within the braces, that's it. You understood what's the magic happening here? Instead of we doing all the things, it is doing the things for us in the backend. the unique ports. If you want to get the unique ports, so we have done like this. So with this, what you understood? So, so filtering we can do in a very short way. Okay, sir. Assume that when you're defining, you don't have things. You already have a list. If you already have a list, then what we can do? So whatever the list of values, which is a running ports is there, which is a list, right? That pass to a function called as set. If I pass to the set built-in function, so don't you see it's automatically creating three values. So means like you pass to that to a set, and again if you want like a list, you convert it. But the problem is that when you do this kind of conversion, you get unique values, but the order may not be the same. So see here 11, 44, and 22. Whereas here the order will be retained. Of course, you are struggling here, right? So that's an advantage. If you want unique values and also the given order, then you go for the first method. If you just want the unique values, you can go for the second method. So this is basically for a set to work with. So what is a set? How it can help us? To understand that, to create a small set, think like this. If you want to create an empty list, either you use the empty braces or like you can use the list operation, right? And similarly, if you want to create a empty tuple, you can use the tuple braces or tuple built-in function. But if you want to create a set, we cannot use the braces like this. If you want to create a empty set, we need to use the set built-in function only. Why, sir? The reason being, you know, a set is used using the flower braces, but the same flower braces is used also by another thing called as a dictionary. So what is this confusion, sir? Same braces for two data structures? Yes, I will tell you shortly. So that's the reason when you use the empty parentheses, it will treat like a dictionary. Or if you want to give also dictionary also, we can give. So whenever you are using an empty set, we should ensure to give this one point. This is the most important point you need to remember. Whenever you are creating an empty set, this is the most important. For tuple with a single value, there is a problem. For a this one like this. But if you have a single element, then there is no problem. If you have a single value, no comma is needed, nothing. You just give within these braces, it's treated as a set. So, and if you have values, we can define the values directly or like indirectly. In Python 2, there used to be a set module also. Means initially sets is not there. Later on in 2.6, I remember, they added sets. So then they created like a separate module. So there used to be module also. But like these are the two things right now we have. Either we can directly define a set within the braces, or if we have any other data structure, we can use a set built-in function for doing it. In both the ways, if you do, so it will result in the same thing. Means if you ask the values, in both the cases, I'm saying assert S1 equal to S2. Means in both the cases, it will create the same set with the same values. So if you see the values, you got it. But I cannot dictate the order in which the values are coming. Means sets are in fact not ordered. So order means what, sir? Means it's not ascending or descending order. The order in which you give may not be retained. Sir, in this case, you give 1, 2, 3. It is retaining the 1, 2, 3. What's the problem? It may not be the same every time. Let me try once again. 4 values are there. Let me give. Now, did you see the order was changed? Sometimes the order may not be changing. It doesn't mean that it is working perfectly. So we cannot have a say on the order. And of course, we are not even interested in this order also. Why means, sets, why we need an order first of all? If you want to index, if you want to slice, you need an order, which is the 0th value, which is the first value like that. But in fact, sets are unordered. If you ask for like, hey, give me the second value, that will say that sets are not subscriptable. means you cannot get the values out of it. And as we cannot even index, we cannot even slice also. Then there is no point of even thinking of indexing, right? So now we understood the concept of unorderedness. Unordered means it doesn't mean ascending or descending. It may not retain the order in which you gave. This is what most important point you need to remember. So simplify. If I want to work on this set, what all things I can do? If I can work on the set attributes, if I create a small set, like a simple set, I'm asking a dir of it. Dir means same like the things. We have things which have underscores on either side. Add is also there, I add is also there. Means set is mutable. It supports in place changes. At the same time, so we can also have a lot of other attributes also. Sets is having a lot of attributes. First, if you want to check things which have underscores on either side, we can do simply like this. You can do set dot underscore underscore contains of 2. We cannot specify at what place a particular value is stored, the index, but we can tell value is present or not, right? So if you want to check whether 2 is present, yes, 2 is present. If you want to check whether 6 is present, we can check it. So either we can use the underscore underscore contains or like in operation. So both will do the same job. If something is present, it will say true. If not, it will say false. In the same fashion, like every object, so we'll have these things. You can use like if you want to get the size, I told we can use the underscore underscore size. Then it will give only the Python object size. But if you use sys.getSize of, it will give along with the C header size also. In this particular case, C header is having 16 bytes, something greater than that. And similarly, uh, till now, every attribute you are seeing, right? But for the first time, you will see one more attribute. It's very interesting. Generally, if I have a set, a simple set, and there is an attribute called as underscore underscore add. If you give a single value, did you see for the first time it is saying like this? Means there are certain attributes in Python they still didn't define it. It is saying that not implemented. Means you cannot add a single element. Means like this you cannot add, but there is other way. So for this it is saying that not implemented. But then what is implemented? You cannot pass directly, but indirectly you can pass. Means you pass like another set, then it will work. To conclude together, if I pass like an individual element, it is not implemented. But if I pass like a set within it, I can do. Means for a set, we can add like that. Okay, further, let me tell you more about it. Let's focus on the attributes which don't have underscores on either side. To do that, we will doing the same thing and we are listing it. We have like add, so remove, pop, all these operations are there. Did you observe? We don't have a position, but still there is a pop. Means which one will be removed? Let's see. All those attributes. So in a list, we have like list.append, list.things, right? Same like that, I can make a comparison. In list, we have like append or insert. We have a particular position, but here the position is not there, but it will add anywhere. Further, there is an attribute called as add. In sets, we can use the add attribute if you want to add something. So initially say, if I want to take the values of the set, I get something. For this set, if I want to add an element, if I add like a 99, so for this set, if I add 99, it will add. So it doesn't mean every time it should add in the starting only. It can add anywhere, it doesn't matter. It has added. First, it will check whether the value is already existing or not. If the value is already existing, it will not add. If not, it will add. If I again do a 99, so now, by now it is already existing, right? So then it will not add. So you get the same result. What if I add something else? Say like I am taking the same example. Say I'm adding like a 45. As 45 is not there, it has added. And did you see the order was changed again? You just added one value, the positions were changed, right? So don't worry about it. And similarly, if I do one more operation, means the same 99, whatever you did, I want to add like this. So what is this? Like a tuple I'm adding. Will it take? Yes, of course. As an individual 99, it's already there, it ignores. But it's a tuple, it's not there, then it will add. Similarly, if I want to add all data types, right? I did with the basic data types like integer. Similarly, float also I can do, none also I can do, fine. But if I go for like adding with a list, how I did a tuple, similarly I'm trying with a list. Now you will see one interesting point that mutable objects cannot be stored in a set. This is for the first time you're seeing, right? You know, what is this concept, sir? Very simple. You cannot add a mutable object to a set. We can add only immutable objects. Sir, what are mutable and what are immutable? So mutable objects means objects which supports in-place changes. So set is also supporting, right, in-place changes because we are able to change. So list, set, next you will see dictionary. These are mutable objects. Whereas immutable objects means what? So basic data types. Basic data types. What are the basic data types we have? Int, float, none, so boolean, so string. These are like the built-in data types, which are all immutable. And also then we will see tuple. Next we will see something called as a frozen set. We will see. These are all like, so immutable objects. So we can add these things. Means if you, for a set, we cannot even add a set also. Because set itself is a mutable object, we cannot add a set also. That is what we need to remember. Sir, can I add a string? Yes, of course. String is immutable, so you can add. If you add, it is adding like this. So now we understood, right? How the add operation is helping us. We can do a lot of operations like this. Similarly, you remember in lists, when you're doing an addition, there is one more operation called as extend. Extend used to not take individual values, only iterable objects it would take. Iterable means any, not the basic data types, anything on which you can apply for loop. Iterable objects means what? So, iterable objects. So objects on which we can apply for loop. The basic data types we cannot do. String we can do. All collections we can do, like a list, tuple, so set, dict. So and like down the line you will see few others like generators, iterators, all those things you will see, range, etc. Those are all iterables only. So extend will take the values and work on it. To understand that, let me take a simple list again, simple set, sorry, and I want to take individual values. So like the basic data types like int, float, long, all these things you cannot do. What is saying? Hey, I created, but I cannot add this one. But if you take like multiple values, like a tuple or a list, then it can take. Now I am taking two values, 8 and 88. So then if you see, did you see both were added in the same dimension? And similarly, so we cannot add a, so in addition, when you're doing, we cannot add a list, right? But here we can add a list because you give any triple, it will go each of the value and do it, right? So it has done. As 8 is already there, it didn't add. 7 is not there, then it added. So we cannot predict the order, just ignore it. And if you have a, what if scenario like this, I have a list of values and it will loop over each of the value and do it. Individually, one is a list, one is an integer. So integer, it's a tuple, it's a tuple. So individually, we can add all those values. And if they were tuple, they were added tuple as it is. 9 as a tuple, 9 as a tuple added. In the same fashion, if I try doing like this, now tell me, individual values is 8 integer, individual value is 7 integer, but this is a list, right? So within that inner value, one of them is a list, so it cannot add. So finally, after doing all these operations, if I say, hey, what is the value of your list? Set, sorry, it will give this is my set. Now for this set, can I add like this one? In fact, this is one of the interview questions. So first value is like this 9, and deep within it, it is a tuple, and deep within it, it has a list. So deep within it, it has a list, then it will throw in error. If you see that example, you see the exception, what message it is showing. You will understand some interesting point. What is saying? Unhashable type list. Means if you want to store something within it, it should be unhashable. What is this concept of unhashable, sir? So only for the immutable objects it will give. So at the outer dimension, it may be a tuple, but deep within it, it has a value, right? That's the reason it is unhashable. So, so if you want to check the hash of any function, there is of course a hash function, which I will tell shortly afterwards, but this is how it works. Similarly, if you want to remove the values, how do you do? Basically, if you want to remove the values from a set, there are three operations. One is set.pop, set.remove, and set.discard. These three are operations. Means each one has their own advantage and limitations, right? So till now we have seen the concept of pop in list. Pop means what? It will remove the last element if you don't specify. But if you specify, it will remove so the value at a particular position in a list. But here we cannot specify the position. We don't know which one is last. Then how it will remove? It will remove some value in random and it don't have a position. So if you are asking pop, initially it removed the 1. Then you got a list, so set. Then you are asking to again pop, it removed 2. 2 is somewhere in the starting. So again 3 it removed, means somewhere it is removing. So randomly it will remove. And if you do the same operation again, or if I do the same operation afterwards also, the result may not be the same. In the same fashion, so pop will remove some value in random. So finally, if the set is empty, it will throw in error. That is also again issue. If you want to specifically remove an element, in a list also we have remove. If there are multiple occurrences, it will remove the first occurrence. But in sets, there will be only one occurrence. So that occurrence, if you want to remove, you can remove it. But here the problem is, if you have a value, it will remove. If that value is not present, then it will throw in error. Say here, from this set, say this set don't have a value called as q. The moment if you ask, it will throw a key error. But what if you want to remove based upon element, but if the value is not present, don't throw in error. If you have that kind of scenario, then go for discard. Discard is same like remove. If the value is present, it will remove. If not, it will stay calm. So it will stay calm and it will give it. Means if you have scenarios like that, you can go with this. And similarly, if you want to create a copy, so I told about the deep copy, shallow copy, these concepts, right? The same concepts you can apply here also. So that is an assignment for you. But here also it has an attribute called as dot copy. So if you see right now, the original object and the new object, the address location is different. So for a single dimension, this copy is fine. If you go for multiple dimensions, we need to go for another thing. And similarly, we have one more thing called as a dot clear. So clear is an operation where it will not remove the values and the object will be present in the same address location, but values will not be there. So did you see the moment I did a clear for the simple list, only the simple list values were changed, whereas a new set value was not changed because it's a safe copy that you created. So based upon these things, a couple of small assignments for you is that, you try the difference of tomato. You take a sum set, so do this operation. In fact, you will learn a lot of things with both set and this thing. Means maybe like I will tell here itself for you. So to understand, say like, I take a my set. I told you empty set when you're doing, you should not take the braces. You do like this. For the set, so my set dot, I can do a add operation of tomato. This is also possible. And similarly, I can do a update also. First, I will do an add and I will see. Add means what? Whatever you give, it will do it as it is. Whereas similarly, if I do like a update, so for the strings, it will go for loop the each value. Means what? When you're looping on a string, what happens? You get one value at a time. Means one character at a time. So it is going to each of the character and adding. And why you got MOT only? Because the characters are repeating. So tomato became a ketchup. So like you got. So this is how it is working. Now, so going for the next is called as set operations, which you want to do. Set operations means basically sets are not just designed to remove the values or get the unique values or like that. We can do a lot of set operations too. To further, so coming to the next thing of set operations. First, if you want to know more about set operations, the most popular way is going for the Venn diagrams. So what is the Venn diagram? If I just Google, you can see the Venn diagrams for anything. Venn diagrams basically will give a clear picture of set operations. When you have two sets, what kind of operations we can do? So means like if there are two sets, A union B, A intersection B, how they are working. By the color itself, we can understand. So total is like union. So in that union, only A or like A minus B or A within it. This is the intersection, means common between them. Union means both A and B and so and so. And you see in this case, all the values of B are part of A itself, like subset. So, and here in this case, both are disjoint, means there is nothing common. So like that, Venn diagrams can help us to understand these things. So basically, if you have different data, so when you're doing a data analytics, this is the most important thing. If I take like two things, say like two sets I have taken, like a rainbow, so means with BR colors, and traffic lights I'm taking. So like this. So there are two things. White will not be there most of the time, but I took like that also a light. I took two options right now. And if I'm asking to print these values, it will print both. So rainbow is there and this is there. Now I'm asking, hey, is it a subset and a superset? So there are two operations called as subset and superset. Subset means is something is part of another. I'm asking, hey, is traffic light subset of rainbows? Means all the traffic lights should be part of the rainbow. If you see in this case, red is there, yellow is there, green is there, but white is not there in this one, right? So as white is not there, it is not a subset. So if the white is also there, then it is a subset. So if I take like in this example, initially, I have taken two examples like this. Now I'm asking, hey, is it a subset and superset? In this case, see what happened? All the values of rainbow are present in traffic lights. And all the values of rainbow are present in traffic lights. So the relation you can understand. Subset. Is traffic lights a subset of rainbow? So, and like is superset. So whichever is like subset and superset, that relation. Subset or superset means like everything of one should be present in another. That is how it works. Similarly, let me take something out of bound. let me take a new set called as the alphabets. It has nothing common, right? So you got like this. So at least one of them is different, then you get this result as false. Now coming to the case of like there is one more attribute called as disjoint. How do you call some two sets as a disjoint? If there is nothing common, it is called as disjoint. If there is at least something common, there is an intersection value, right? Means if both are disjoint, means there is nothing common between them. So if there is something common, means there is some intersection, means they are not disjoint. Simple logic. So if I do the same, you can understand it. Hey, so whether both are disjoint or not, it says false because there is some common. If you ask, hey, what is that common? It will say these three are common. Similarly, if I ask, hey, what is common between alphabets and this rainbow means? Alphabets has all alphabets. There is nothing common, right? As there is nothing common, it will say disjoint is equal to true. And if you ask intersection, it will say empty set. So whenever there is a disjoint only, you will see this kind of issue. So now we understood the concept of superset, subset, disjoint and intersection. Now the second point with the set is whether sets support concatenation. We have seen the concatenation in a list, so in tuple, but sets doesn't support the addition operation, means concatenation. At the same time, set supports the difference operation. Set difference concept is slightly different. If I ask a Venn diagram of set difference, you can notice it. Set difference means like if there were two sets and if you want to get the difference, so you get what are all the values of set minus the intersection. So if I say like C minus D, what I'm getting in this case? So from C, what are all common between C and D? If you do the remove the intersection values, then you get only the yellow color values, right? That is C minus D. Whereas D minus C means the blue color. So means like from D, what are the things which are common between C and D? If you remove, you get it. So set difference means like if I ask, hey, give me, so this rainbow minus traffic lights. So rainbow has a lot of colors. From that, if you remove the traffic lights, you get the remaining values. Whereas from traffic lights, it has only three. So if you remove all the rainbow colors, it got like empty. So from the first set, we will remove all the common things. So, and you get the result. That's the reason in the second set, as traffic lights has only three, if you remove all the common things, you got like nothing. So that is the set difference. Similarly, union means what? Getting a combination of all. I think here you don't need some kind of picture to illustrate. So if you want also, you can say the same. Set union operation. So union. If I do union, I want the combination of all. You see, A union B means you want a combination of both. A intersection means like this. So A set difference, I will tell you shortly. But union means I want both of them. So that's the reason union operation is commutative property. Whether you do set 1 union set 2 or set 2 union set 1, both will give the same result, right? Of course, the order we cannot dictate, but like total values will be same. And similarly, whereas if I do intersection, intersection is also commutative because if I say A union intersection B or B intersection A, both will give the same common values, right? That's the reason union and intersection both are like commutative. Whereas coming to the case of set difference, I told you this is called as a union, whereas this is a intersection. But what is A set difference means? Take the total union, from that you subtract the intersection. Means individual values of A, individual values of B. So remove the common values. That is set difference. If you want the set difference, so Python came up with one operation for that, for set difference called as symmetric difference. Symmetric difference means A union B minus A intersection B. If I do, you get the exact same thing. Means in the total values, you remove the common values. You get the remaining. So in the total union values, you remove the common values. That is what happens. So, and like this is all about the set operations. The next thing that you see is about mutability in sets. So you need to understand that sets are mutable. And there is one more thing called as frozen set. Frozen sets are immutable. What is these two things? How they can help us? So let's see now. Sets are mutable, whereas frozen sets are immutable. What is this and how it can help us? If I say, if I create an ordinary set like this. So if I create an ordinary set, I'm asking the values, I get it. As we have an indexing is not possible, we cannot do directly, but we can add a value, right, to a set. You can do an add a value, and if you ask, you can see. Position we cannot determine, but like we can do the changes. So whatever the values are there, it happens. So, and if you want to further see even the address location, I can say like ID of, oh sorry, ID is already there, right? Yeah. ID is like you see here, the address location is not changed, but the values were added. So with this, we can conclude that, so changes are possible. So it is mutable, ordinary set. Whereas if you want to create a frozen set means same like the set, but we pass to another new built-in function called as a frozen set. I think by today I told nearly some 35 to 40 built-in functions. There is a new function called as frozen set, like a set. So we need to pass to that. If I pass to it, it becomes a frozen set. For a frozen set, same like an ordinary set, if you try to add the values, say like I'm doing trying to add, then it will throw an error saying that frozen set don't have the editable attributes. Means for an ordinary set and this frozen set, if you compare the dir, you will see the difference. If you see, the first one is ordinary set, second one is a frozen set. The basic additions are there, but if you see further in the last values, did you see that it is not supporting those many operations? So we have like intersection, disjoint, all these things are there, but don't we, frozen set, we don't have like add, clear, all these things we cannot do. So that is the difference between a ordinary set and a frozen set. So due to that, till now that in an ordinary set, we cannot add a set within a set because set is a mutable. Mutable objects can't be added within a set. So that's the reason we cannot add an ordinary set in a set, right? But we can add a frozen set. So that is possible. You see, if I add a frozen set, that is possible. It will take a frozen set. So that is the difference between an ordinary set and a frozen set. So primarily frozen set is designed to make it unique. So what are the changes you want to make, you can do there, but you get it. And again, like, there is one of the interview questions. So this is one of the problems, okay, which was asked. Interview question problem. To get the uncommon word. So I was asked a question. So means like I was given like two word sets. So there is word set 1 and word set 2. In these two things, so there are certain things which are common, like San Francisco, San Diego. San Diego is common, Los Angeles is common, but like others are not common. So if you want to get the common words, then how you do? You get like intersection, right? So if you want all the words, how to get the all words? If you want, I go with like a union. All words, if I want, I got like, word set 1 dot union of word set 2. And if I print f of all words is equal to, you can see all the words you got. But what if you want uncommon words, means things which are not common? So for that, we can go for something called as the symmetric difference. So means like you got the uncommon words. So like this also we can do. And also you remember we have other operations. A union B minus A intersection B. For that we have something called as symmetric difference. Symmetric difference of the second set. If you have two sets, if I ask, so don't you see whether I do this operation or like the other operation, both are giving the same values? Is it clear, everyone? This is also called as a symmetric difference operation, or we can do the symmetric difference operation using this attribute. So whether you can use this attribute or this one, both will do the same job for the symmetric differences. And lastly, we have the dictionaries. So which we will touch with.